3 of 7.2 is compounds with radicals. So remember that a radical may be included in a parenthesis when you write it, but it does not have to be. Sometimes it does. So basically, you're going to say the name of, write the symbol for the chemical from your periodic table, the element, and then you'll write the symbols that make up the radical from your radical sheet. You can always put radicals in parentheses, but you don't necessarily always have to. And then you check the charges just like you did before. The element's charge comes from the periodic table. The radical's charge comes from the radical sheet. And then if the charges need to be canceled, you crisscross them and make the charge the subscript if necessary. The only thing is, if you're adding a subscript to a radical, you have to have it in parentheses. And I'll show you why in a minute. So this is the most common situation, an element followed by a radical. But remember, you could have a radical and then an element. Same thing, write the radical symbols in parentheses if you want, write the element symbol, check the charges, cross to cancel if necessary. Or a very rare situation, you could have two radicals. Write the first radical's symbols, write the second radical symbols, check charges, cross if necessary. So I think it's best to just see some examples. Okay, so potassium cyanide. So I have an element and a radical. So potassium is K, cyanide is Cn. So if you want to put this in parentheses right off the bat, you can. Parentheses can never hurt you. If you don't put parentheses and they're needed, that will hurt you. So then I'm going to check my charge. Potassium from my periodic table of elements is +1. Cyanide from my radical sheet is -1. I'm looking at Cn as a whole, not C and N separately. They cancel out. So my final answer is KCN, or you can write it K parentheses Cn, whichever you prefer. So very similar to the binary rule, except now you have radicals. Okay, aluminum silicate. So once again, an element and then a radical. And if you're not sure if there's a radical, check your radical sheet. Most radicals do end in ATE or ITE, but you do have some that end in IDE. So just check your radical sheet if you're not sure. So aluminum is Al, has a charge of +3, and silicate, SiO3, and the charge of silicate from my radical sheet altogether is a -2. So these do not cancel, which means I have to crisscross. So the 2 is going to come down and become aluminum subscript, and the 3 is going to come down and become silicate's subscript. Except I can't write it like this. Al2 SiO3 3. I can't write it like that because now it looks like there's 33 oxygens. I need to have 3 SiO3s. So instead what you have to do is now you have to put parentheses. So if you're adding a subscript to a radical, crossing charges to cancel, you have to put the radical in parentheses. So SiO3 is my radical, and then I'll add this 3 to the outside. So my final answer is Al2 parentheses SiO3 parentheses 3. And if you just said Al2 SiO3 3, it would mean the same thing. I'm not saying Al2 SiO33. Okay, so if you're adding a subscript to a radical, you have to include parentheses. But for this one, we weren't putting a subscript, so it was optional. Okay, moving on. Calcium hydroxide. Calcium is Ca. The charge is +2. Hydroxide, not hydride, which is H. Hydroxide is OH, and it's a -1. They do not cancel, so I'm going to have to crisscross, except what do I have to do? I have to put OH in parentheses. So the 1 was here, which we don't write, and then the 2 is going to go outside the parentheses. CaOH2, not CaOH2 like that. In this case, we're saying 2 H's and 2 O's. this is correct. In this situation, we're saying 1 oxygen, 2 H's. Incorrect. So once again, biggest mistake I see, if you're adding a subscript to a radical to cancel charges, you have to put parentheses and then put the subscript on the outside. Okay, sodium acetate. Sodium is Na, charges +1. Acetate is a big radical, C2H3O2, and that whole thing has a charge of -1 from the radical sheet. These cancel, so I don't have to do anything. So your final answer is Na, C2H3O2, just written like that. Or you can write it with the radical in parentheses. Like I said, parentheses can never hurt you, but in this case, you had to use it. All right, try one more together. Ammonium phosphate. So now we have 2 radicals, ammonium, which is NH4, charge of +1, and phosphate, which is PO4, with a charge of -3. So remember, I'm not looking at the charge of phosphorus and oxygen separately. This charge is from your radical sheet. They don't cancel, so I'll have to crisscross. So I will have to put parentheses around ammonium. That 3 is going to come down. And then the 1 comes outside of phosphate, but we don't write 1s. So just PO4. Or if you'd like parentheses, you can write all of it in parentheses. You could do that, and then you could do that. Okay, so try some on your own. Pause the video. So number 2 is the trickiest one because peroxide's a weird radical. So you've got an element and a radical for all of these. So the most common type you'll see. So try these out, check your answers. Okay, so check these out. So the first one was sodium Na hydroxide OH, both plus and -1, they cancel. So my final answer, NaOH, or you could put the OH in parentheses. Second one, hydrogen +1 H. Peroxide, in this case, is a radical O2. I know that's slightly confusing, so I just threw it in parentheses to show you it's not oxygen. Peroxide's a radical. So then my final answer is H2O2 because I had to crisscross the charges, or you could have H2 and O2 in parentheses. Barium +2 Ba, phosphate PO4 -3. I had to crisscross both of these, and because I'm adding a subscript to the radical, I had to put parentheses around PO4. So my final answer is Ba3 and then PO4 with parentheses 2. Always make sure you add that. You can't have PO42 without a parenthesis. Okay, last one, calcium carbonate. Both have a plus and -2 charge. Calcium Ca, carbonate CO3. The charges cancel, so I don't have to write anything. So you can write it this format, or you could put carbonate in parentheses. So that is compounds with radicals, writing the actual chemical formulas.